And so this tutorial is going to be especially useful to you if you're starting with three-dimensional contours. So in other words, if I sort of orbit to a view that's closer to the ground, I can start to see that my contours have varying z values. Alternatively, you might have contours that have been flattened and they're all sort of projected, they've been projected to the XY plane of your model. If you don't have three-dimensional contours, you might look to one of the other tutorials. Through this tutorial, we're going to use Grasshopper, which is a plugin for Rhino, to create a NURBS surface from those elevated contours. I have one that's sort of pre-made here, so I'll just turn that layer on, and I can show you that this is a type of surface that you might be able to get from this tutorial. You can see that a NURBS surface is a sort of smooth surface. Along the way in this tutorial, we're also going to produce a mesh. The difference here from the NURBS surface is that a mesh is made up of a series of planar surfaces, so it's not quite as smooth. It's made up of a series of these triangles. Each of these triangles is perfectly planar. I'm using a Windows-based machine, and I'm using Rhino 5. And so I've installed Grasshopper onto this machine as a plugin to Rhino. If you haven't done that already, you can do that by going to www.grasshopper3d.com, and if you go to the download tab at the top, you can see that they have a variety of versions based on your Rhino. Grasshopper is now included with Rhino 6, so if you're running a brand new Rhino, you won't have to do this. You won't have to install the plugin. You'll have it automatically. So just one more note before we get started. Also in the source files that you can download from Polylearn is a PNG, and this is an image of the definition that we're going to be making in Grasshopper, and you might find it helpful. It's got some instructions on it, and you can sort of reproduce the definition from this. If you haven't done so already, you might go ahead and download and open up the source file, which is Chamisol topography. There may be a number of Chamisol topography source files available on Polylearn that have been used for the other tutorials. I think that any of those will be fine, so long again as you have elevated or three-dimensional contours. If you do a little bit of clicking around, you can see that my contours happen to be joined. You may have gotten your contours from GIS, from a digital elevation map. And in that case, sometimes you'll find that these contours come in a bunch of small parts. That should work. If it does give you problems, you may also want to just go ahead and join those contours. The easiest way to do that would be to just select all of the contours and type in join. You can go ahead and open up Grasshopper, and you would do that by typing in Grasshopper into the command line, and you'll see that that opens up the Grasshopper canvas. And so I'm just going to sort of organize my windows here so that I can see both Rhino and Grasshopper at the same time. Okay, so if you haven't used Grasshopper before, Grasshopper is a plugin to Rhino. You need both Grasshopper and Rhino open in order for it to work. In the Grasshopper canvas, we're going to insert what are called components from these pull-down menus, and we'll in most cases we'll try to link those components to the geometry that you have in Rhino. So the first thing that we're going to want to do is we're going to want to get a curve component. And so I'm in the parameters tab looking in this geometry panel, and you can see that I have symbols for things. The curve is this one, looks like a spiral, so I can click that, and then with a second click drop it into the canvas, and then I have it sitting there. Another way to do this would be to double click into the canvas, and just like in Rhino, you can sort of search for what you need. So I can type in curve, and it gives me every component that's available that has the word curve in it. And so there again I see the the curve component with the spiral. So I have another one. In order to get rid of this, I can select on one and I can type in delete. If you're using a Mac, you might have some trouble with the Mac keyboard and deleting. So if you can't just simply delete the component, what you might do is hold down the function key and then hit delete. And sometimes that takes care of the problem. Okay, so we have this curve component, and if I don't have it selected, it's orange, which is Grasshopper's way of telling me that it's not connected to anything. It's a bit of a yield sign, and so it's telling me that there's something not quite wrong with this component because it's not broken or anything, but it's not quite functioning either because it hasn't been linked to Rhino. So in order to do that, I'm going to right-click on the curve component, and about midway down in the panel there are two options. One's called Set One Curve, and the other is called Set Multiple Curves. And I'm going to want to put all of our Chamisol Winery contour curves into here. So I don't want one curve, I want to put multiple curves in. And when I click this, it's going to send me over to Rhino. You can see that in the Rhino command line, now I have a sort of prompt to select the curve. And so I'm just going to select all of them at once by windowing. And once I have the selection that I want, I'm going to hit enter. And now you can see in Grasshopper that my curve component is no longer orange. It's gray. And I also have a set of curves that are referencing in Grasshopper that are referencing my Rhino curves. So incidentally, Grasshopper is considered a parametric software, which means that it always stays up to date based on sort of changing parameters. And one of those parameters is now these curves. So if I were to move the curves in Rhino, the Grasshopper curve adjusts as well. Okay, so we have we've now sort of linked our Rhino curves into Grasshopper, and we can move forward. You might find this next step is necessary if your contours look like mine. You can see that these contours are maybe have a bit too much detail. I think that this is probably an error. It would be pretty unlikely for the ground to actually be shaped this way. So I think what's happening here is that these jaggedy lines are a product of how these contours were made in GIS. And so instead of just moving forward with these, I'm going to try to rebuild these curves so that we can edit out some of these things without having to do it manually. I'll try to rebuild all of the curves at once. So I'm going to double click in the canvas and ask for a rebuild curve component. So it looks like this one here. And there are a few inputs. So in Grasshopper each component has inputs on the left hand side and it has outputs on the right hand side. And if you can't see them, you can sort of hover over the input and it'll give you a window that tells you what it is. So these are the curves to rebuild. And so I want to take the output from my original curve component. I want to click on that output, and while holding down on the mouse, I want to drag it over to the input, and it'll allow me to plug it in there. And you can see that that's giving me some rebuilt curves with very few control points. So what we're going to try to do is use the rebuild curve command in order to change the number of curve control points that each of our contour curves has. So for instance, if I click in Rhino on the original contours and I turn the control points on, I can see that there are just a lot of control points in there. And so let's say that there are 1,000 control points in here, just kind of ballparking. If I reduced this down to 100 control points, I might be able to remove the kind of jagged character of this line. So I'm going to click Escape to turn off those control points, and look back in Grasshopper at the inputs. and I can see that I can change the degree of the curvature of these curves. So a 1 degree curve, for instance, is made up of straight line segments. A 2 or higher degree curve is more of a curvy curve. If I go down to the end, this is going to be the count, so the number of control points in each of these curves. And then this is another toggle that you can set true or false, whether you want to preserve the curve tangents. And so I'm just going to keep this at false. We won't use this this input. So let's take a look first at this second input, the degree input. It's expecting a number between 1 and 5, and so it's possible that you might actually want to change the degree of this curvature, and Grasshopper, being a parametric software, would enable you to do that. So what I'm going to do is create a slider where I can slide through some numbers from 0 to 5. So if you were to double click in the canvas and ask for a slider, you can see that there are a couple of sliders here, and the one that you want is a number slider, the second one up. And it comes in as a slider with this button here that you can slide, and as it stands, it slides from 0 to 1. And this is a float, so it has decimal points. And so we really want numbers, whole numbers from 0 to 5. And so I'm going to want to edit this slider. And you can do so by right-clicking on the slider and typing in, or going down to select Edit. So in the editing panel, the first thing you want to look at is the slider accuracy, and it's set to 3 decimal points. So if we were to click integer as opposed to floating number, so click on the N as opposed to the R, that's going to that's only going to allow you to use whole numbers, and it'll take out the decimal point. If then we look down at the numeric domain, a domain is a range from the minimum to the maximum. And so we're going to, the minimum is set to 0, so we're going to keep that where it is. The maximum is set to 1, and so we can sort of change this to 3 or 4. There's not much difference between a 3 and a 4 degree curve for our purposes, so we might just say 3. Click the green check button, and so when we say OK now, we should have a slider that now goes from 0 to 3, stopping only at the whole numbers. And so I can go ahead and take the output of the slider, plug it into the D input of our curve rebuild, and I can see now, looking at our new rebuilt contours, if I were to if I change the degree, I get a slightly different type of curvature there. A 1 degree curve being straight line segments again, 2 and higher being more curvy curves. Okay, so the next thing I want to do is take a look at the count, or the number of points that we have in there. And similar to the degree, we're going to want to be able to adjust this on the fly. So I'm going to create another slider, double click in the canvas, but this time instead of typing a slider, I want to show you a shortcut for maybe not having to edit the slider so much. So if you, instead of typing slider, if you type in the number 100, you're going to get a number slider that goes between 0 and 100, and it only uses whole numbers. So we can plug that into the N, and you can see now that with 64 points on each curve, I get I get curves that are much closer in proximity to the original contours, but they have removed those kind of jaggedy lines. One thing that's interesting here is that our contours have a variety of lengths. So this contour, for instance, maybe this contour is a mile long, whereas this contour, which closes in on itself, is much smaller. Maybe it's only 50 feet. And so I'm getting 64 control points along this short curve, but also 64 control points along this long curve. So one thing we could try to kind of increase our accuracy would be to set the number of control points based on the length of the curve. So what we can do here, and I'm just going to pull our original set of curves back a little bit, we can ask Grasshopper what the length of each curve is. So I'm going to double click and say length, and it's this first one at the bottom here, length. And if I take the input, if I take the output of my curve, I plug it into the input from the length, I don't get a sort of response in terms of geometry, but I am going to get a series of values. If I hover over this, the output here, I can see a series of values, 127, 271, 525, etc. if I read down in that panel. These are referencing whatever your units you're using in Rhino. So if your Rhino is set to inches, this would be 127 inches, 271 inches. So there's a length for each of the original contours. So I'm going to take this length and I'm going to divide it by some number. So I'm going to double click and ask for a division. So division like A divided by B. And I'm going to plug the length into the A input of the division, and then I'm going to want to divide the length of that curve by some number. So I'm just going to go ahead and use the slider that I had already made. I think it's working fine. Going between 0 and 100. I'm going to take that down a little bit, and I want to replace now the original slider that I had plugged into the number input with this new result, this new division. So I'm just going to replace something. I can just take the output of the division and kind of replace into the input of the number. And you can see that removes the original slider that we had in there and replaces it with the division. So let's take a look now in Grasshopper. If we adjust this slider, right now it's set to 30. The length is being divided by 30, and it looks pretty good. We're sort of we've removed all of these imperfections in the line. It's not exactly on. One thing that we want to look for is places where the contours might be overlapping each other, and it's hard to see with both curves on here. So I'm going to unpreview the original curves, and you can do that by right-clicking over it and clicking the preview button, and then they sort of, at least the Grasshopper version of them disappears. I can still see the Rhino version, but at least it's easier for me to separate them. So what I'm looking for is places where the contours overlap each other, and what I mean by that, if I were to increase this slider, let's see if I can do it. There we go. Back in here somewhere, I had a place where the contours overlapped, and that isn't possible with contours, so I just want to sort of adjust this divisor until I don't have any of this type of overlap. So down around 30 looked pretty good. I didn't see any of that in there. And I'm just going to kind of spot check, looking through the contours to make sure that I'm getting what I want out of it. I'm getting rid of all these kind of jagged pieces, but that I don't have any overlap. And so this is a good spot to look for overlap. And it looks like these contours are separate. The red and the black are okay to overlap because those are not the same set of curves. But I just want to make sure that nothing in this new red set of contours that I have here overlaps. Okay, so this looks pretty good. Okay, so now that I have these contours rebuilt in Grasshopper, I'm going to go ahead and turn off the contour layer in Rhino, just so it's a little bit less distracting. I will open up the Layers palette, and I'll go ahead and turn off the topography layer so I don't have that overlap, and I can see things a little more clearly. So the next thing that we're going to do is we're going to divide each of these contour curves into a series of points. So if you were to double click in your canvas and type in the word divide, the first option you get is a divide curve, and the symbol is a series of points along a curve, which is exactly what we want. So I'm going to drop that into the canvas. I'm going to take the output from my rebuilt curves and plug it into the C input. And already you can see that I have a result here. Each of these contours has a series of points on it. And if to understand what it's doing so far, if I were to hover over the N input, I can see that it's divided each of these curves into 10 segments. So what we want to do is create a sort of resolution of points here that will give us a fine enough mesh and surface without being kind of overly fine and then sort of too heavy in terms of the file size. So I'm going to want to increase this number. And similar to what we did before with the length, we're probably going to want to set this up so that longer curves have more points and shorter curves have fewer points. So we can actually use this exact same setup where we evaluated the length of the curve, then divided that by some number and got a result. We can take that result that we previously used in the rebuild, and we can also use it to set the number of points on the curve. And you can see that in my doing that, I get a series of points that are much closer together on each curve. And also, because we used the length in this divide, I can see that on long curves, the spacing between points is the same as the spacing between points on short curves. So I'm going to get a nice smooth surface out of this set of points. Okay, so we can use these divide points now to create a mesh which approximates the shape of this topography. So I'm going to go up to the mesh pull down under triangulation, and I'm going to look for a tool called Delaunay Mesh. And for some reason, at least in my version, Delaunay isn't searching when you double click into the canvas, so I'm just going to go ahead and grab it manually. And I'll drop that into the canvas. And I'm going to connect the point output into the point input of our Delaunay mesh. And you can see right off the bat that the mesh is turned red, which is Grasshopper's way of telling me that there's some problem with it. And the problem is a little bit complicated, but it has to do with the way the list of points is organized. So if you remember, we created this set of points by dividing each of our curves. So the list of points in this divide component have a hierarchical organization which understands that step-by-step process of using the points as a starting point. And that hierarchical organization is not what the Delaunay mesh was expecting. So Grasshopper has a way of dealing with that, and they call it flattening the list organization. So I'm taking a list which has hierarchy and I'm flattening that hierarchy. So I'm going to right click on the P input, and I'm going to select the tool with the down arrow that's called flatten. And that's going to place a down arrow next to the input, but also takes the red warning sign off of the component. So anytime in Grasshopper you see either an up arrow or a down arrow, that's letting you know that the list organization has been adjusted, either by flattening it, taking away the hierarchy, or by what's called grafting it, which means adding hierarchy. So now we have a mesh which is approximating our topography. It's difficult to see, so I'm just going to turn off a few things. I will unpreview the divide points by right-clicking and saying preview. That takes that out of there and allows me to see a little bit better. It's hard for me to see how close my mesh is to the contours because there's no sort of articulation on this mesh. There's no iso curves or intermediate curves to it. So I would like to see those just so that I can make sure that there aren't any problems. So in addition to the Delaunay mesh, I'm also going to add, if I go up to the mesh tab and triangulation, I'm also going to add the Delaunay edges, which would show me the edges of each one of the planar triangles in the mesh. So I'm going to select that. I'm going to do the exact same thing that I did to the mesh. I'm going to flatten, right click over the P, and I'm going to flatten the point input, and then I'm going to grab the point output from the divide component, and I'm going to plug it into the point input of the mesh edge component, and then I can sort of take a look. This gives me a better understanding of the shape of this surface, and I can see that on one hand I have fairly similar sized triangles making up this mesh, which is good. It's a nice even mesh, except for of course places where that's just not possible, like these low points here. And I also don't have any kind of meshes with intersecting faces, and you can just sort of scroll around and look to see if there aren't any problems. Okay, so that's about half of our tutorial. We have a Delaunay mesh. You can bring this into Rhino and you could use this to sort of design off of, to place your building on, and or to simply to visualize the topography. In the next part of this tutorial, we're going to go ahead and also produce a NURBS surface, which would be a much smoother surface as we discussed at the beginning.